This is a video to prepare you to learn about the atom structure. Remember, at any time, feel free to hit the pause button to fill in the notes you were given in class. Your job is to listen to the video and fill in the blanks. So let's start with atomic structure. General atomic structure goes like this. Atoms are made up of protons, neutrons, and electrons. Inside of an atom is the nucleus of the atom. Inside the nucleus has protons and neutrons. We say that the nucleus is positively charged since the neutrons inside the nucleus do not have a charge. They are considered neutral. On the outside of an atom are the electrons. They travel outside of the nucleus in what's called electron orbitals. So again, you want to know the basic particles of an atom. We have protons and neutrons inside the nucleus and the electrons on the electron orbitals. Here is a picture of the protons, electrons, and neutrons in a much larger view. Please fill this in your diagram so you have a model of what an atom looks like. Remember, these are very, very small. Protons are located in the nucleus. They have a positive charge, so think pro-positive. They have approximately 1 atomic mass of a mass unit. Particles in the nucleus each equal 1 AMU. The number of protons equals the atomic number, which as you can see is really small. When we look at the number of protons, it helps us identify what type of atom it is. Each atom composes of different elements that make up specific properties. So a proton, you need to know, is in a nucleus. It has a positive charge, and it's really small. It has a mass of approximately 1 AMU. The neutron is also located in the nucleus. It has what we consider a neutral or no charge. It also is about 1 atomic mass or 1 AMU. Neutrons have no charge and have the same mass as a proton. Again, these are located inside the nucleus. So protons and neutrons are inside the nucleus. Let's talk about the nuclear details. Inside, we have protons and neutrons that make up most of all the mass of the atom. They are really small and have little volume. However, they are very massive in retrospect to the size of an atom. Inside the nucleus, there's lots of mass and a little bit of volume, but they're incredibly dense. Remember that video clip I showed you about the 1-foot box fitting 6 million cars in it? It's very dense. So the nucleus of an atom is very high in density. It has a little volume, but it's very massive as far as the amount it takes up in an atom. Remember, most atoms have empty space in them. Electrons are what's on the outermost part. They are on what's called the electron pathways, or also known as electron clouds. These electrons travel around the nucleus. Again, remember, there's a lot of empty space here. They have a negative charge. Their mass is 1 over 1,836 of an AMU. It's so tiny that we pretty much ignore it as a mass, because most of the mass is here in the nucleus. The electrons that orbit around the nucleus of the atom have what's called the 2-8-8 rule, electrons filling up the pattern. Think of it like a maximum capacity in a room. You have electrons that can fit on the first ring. Now only 2 can fit on this ring, and then 8, and then 8. These are how the electrons fill up on the rings. This helps in bonding with other elements. Charges in an atom, again, negative charges of an electron cancel out the positive. So atoms are what we call electrically balanced. The number of protons equals the number of electrons. We keep them balanced because the positive and negative charges balance each other out. Unbalanced atoms have more or less electrons. We call those ions, and those have a charge. For the elements on the periodic table, they have the same number of protons and the same number of electrons, so they are balanced positive and negative charges. When you look on the periodic table, this is a chart that helps you figure out what's going on inside of the atom. On a periodic tile, it looks like this. We have the atomic number. That tells us the number of protons in the nucleus and the number of electrons, because if we have a certain number of protons, we have to have the same number of electrons, so that positive and negative charges even out. So for example, if we look at this sulfur, the atomic number is 16. That means sulfur has 16 protons, and we can infer that there are 16 electrons. This number right here is called the element symbol. We abbreviate them, and we always make sure the first letter is always capitalized, and if there is a second letter, it's lowercase. So for example, this is sulfur, represented as a capital S. We will be practicing the very popular elements and their symbols. Then underneath your element symbol is the atomic mass number. This is the total number of protons and neutrons in the nucleus. So you can see this atomic number is available for us to see in the periodic table. We will be practicing this quite a bit in this unit. We use Bohr models to represent what an atom might look like. So for example, if this is an atom of sulfur, we know the atomic symbol is S, and that its atomic mass, if you remember here, is 32. Now how do we get the number of neutrons? Well, this is very simple. If the atomic mass number here equals the total number of protons and neutrons in the nucleus, I'm going to do a little bit of subtraction. I'm going to subtract the atomic number from the atomic mass to find the number of neutrons. So when I do that math, 32 minus the 16 for the atomic number, I would have 16 neutrons and 16 protons inside of the nucleus. We will practice this quite a bit with some models. We will do it with a Bohr model that shows a representation of the atomic structure. Okay, I want you to practice the lithium Bohr model. See if you can figure out where the electrons will go. Remember, they're filling in a 2-8-8 pattern. So let's check your work. You should have electrons on this. So again, we have 3 protons. That means there has to be 3 electrons. 2 fill in on this, and then our outermost fill. Okay, let's try oxygen. Draw the Bohr model for oxygen on your paper and see if you can fill in. Pause the video. Okay, let's see if you got it. We have 8 protons, again represented by the number here. Our atomic number is 8, so there are 8 protons. Okay, over here I have my oxygen symbol and the atomic mass. So I know if I have, and I have to round here, 15.9, I can round to 16. 16 minus 8 is also 8, so that means I have 8 neutrons. So remember, I am subtracting the atomic mass from the number of protons. And then I'm going to fill in the electrons here. If I have 8 protons, that means I have 8. So I'm going to fill in 1, 2, and then I'm going to be placing the other around the outermost. And there can be up to 8 on that one. So when I do it, I should have that. Now try example. Here's another example of beryllium. You can see they can get quite large. So we will practice more in class. This is to give you a basic understanding of what's inside of an atom and to get some practice thinking about what the positive and negative charges are and how to count an atom.